In this video, we're going to be looking at simple depreciation. Simple depreciation or decay, it's also known as decay, occurs based on the simple interest formula. Okay, and this is also known as the straight line depreciation method. So this is the simple depreciation formula. So if you're going to be looking at your formula, it's exactly like your simple interest. The only difference in your simple interest is that it uses plus RT, yeah. But in depreciation, we're going to use the minus sign in there. Okay, so if you're going to be looking at its part, it's almost the same like your simple interest, where your A is going to be the total value after depreciation, P is the original value, we also call it the principal, R is rate, that is written in decimal form, and T is time period. Depreciation is constant, so it is a straight line graph with a negative slope. So always remember that it is a constant, and what makes it a straight line is because of this straight line that you can actually see. That's the very reason why it's called a straight line method. Here is an example. A company computer assets depreciates at 10% PA. If the value started off at 20,000, determine the value of the assets after 3 years. Okay, so let's recognize our given here. Our P here is 20,000. Our rate is 10%, which is also written as 0.1 or 0.10. They are the same. And our time here is 3 years. Okay, putting it in our formula, A is equal to P1 minus RT. So that's going to give you 20,000 multiplied by 1 minus 0.10 multiplied by 3 years. So this is going to give you an amount of 14,000. Okay, so at the end of 3 years, the only amount of that computer assets that depreciates at 10% is only $14,000. Here's another example. A car worth 120,000 depreciates at a rate of 12% simple depreciation. How much will the car be worth after 5 years? So here our given is 120,000. Our rate is at 12%, which is also the same as 0.12, and our time here is equal to 5 years. Okay, so putting that in our equation at the end of 5 years, that's gonna give you 120,000 multiplied by 1 minus 0.12 multiplied by 5. So putting it in your calculator, this is going to give you around 48,000. Okay, that's the cost of that after 5 years. So here's another one. Fiona buys a DSTV satellite dish for 3,000. Due to weathering, its value depreciates simply at 15% per annum. After how long will the satellite dish have a book value of 0? Now we can actually have two approaches in here. First is we can just simply look at the depreciation, which is going to be the 3,000 principal multiplied by 15% to give us the depreciation per year, and that's going to give you 450 per year. Now with this information, then you can get now the time, which is 3,000 divided by 450 per year. Okay, then this is going to give you around 6.6667, or simply 7 years. Yeah, or there's another way also using our formula. Okay, so here our formula is A is equal to P 1 minus R and T. So they said that What's going to be the total value of that? It's going to be 0, and that's going to be 3,000 multiplied by 1 minus 0.15. Okay, and then we're going to multiply this by your time. We don't know the time in this case. Okay, so that one. So we're going to divide everything by 3,000. 3,000 to separate this part. Okay, of course, on this left hand side, it's still going to be 0. Here you're going to have 1 minus 0.15 multiplied by t. It's going to give you this one. So we're going to put this one on the other side. So that's going to give you negative 1 is equal to negative 0.15 t. Yeah. Then we both divide by negative 0.15 to isolate t. This is negative 0.15. Therefore, if you're going to have here, the time is going to be negative 1 divided by negative 0.15. And if we both divide a negative and a negative, we're going to have a positive, which is going to be the same as 6.667, or simply around 7 years. So whichever you're going to use in this, it's actually going to be the same. So here's another one. 7 years ago, Rocco's drum kit cost him 12,500. It has now been valued at 2,300. What rate of simple depreciation does this represent? So let's take note on the first. It says 7 years ago. So that's going to be time. And then it says 12,500, which is our principal. It's going to be 12,500. It's valued, but the final value A is equal to 2,300. And what is missing in here is the rate. Okay, what is the rate? Okay, let's put that in our formula. Okay, our A here is 2,300. It's equal to 12,500 multiplied by 1 minus our rate. We don't know our rate, but we know our time. So 7 times R. Okay, we divide both by 12.5. Okay, to isolate. So on this side, you are left with this only. 1 minus 7R. And if we're going to divide this one, this is going to give you around 0.184. Okay, so let's continue. Now, the next thing we're going to do is to put this one on the other side. That means 0.184 minus 1 is equal to negative 7R. Okay, simplifying this one, it's gonna give you negative 0.816 is equal to negative 7R. Dividing both by negative 7 to isolate R. So your R here now is going to give you around 0.1165 714. Okay, let me just, and I'm going to multiply this with 100% to get its real rate. So that's going to give you around 11.66. Yeah, that's one more there percent. So this is the rate of depreciation in here. Here's another one. You bought your very first MacBook Pro at 3,800. Due to excessive use, its value depreciates simply at 15% per annum. A. After how long will your device have a book value of $1,200? And B. After how long will your device have a book value of 0? This is very interesting. So first, let's look at letter A. In A, let's our formula is equal to A P1 minus RT. So they said the book value here will be 1,200. So that's going to give you 1,200, and your principal is going to be 3,800 multiplied by 1 minus 0.15 times, do we know the time? No, we don't know the time. Then we just multiply it by t. Okay, we divide both by 3,800 to isolate. Okay, it's going to be 1, and this is going to give you all around 0.31578. Then here's going to be 1 minus 0.15 t. Okay, there you go. Now what we're going to do is we're going to transfer it on the other side. So that's going to give you 0.31578 minus 1 is equal to negative 0.15 t. Okay, simplifying this one is going to give you negative 0.6842. Then still this is going to be negative 15t. Now we're going to divide both by negative 0.15 in order to isolate the t. That's going to just be 1, and this is going to be negative 0.15. So the final answer here is going to give you 4.56 years. Okay, that's the first answer. The second one in here says that how long before it's going to become 0. So let's look at letter B. Letter B. So A is equal to P1 minus RT. It says 0. The final amount is 0. Then our principal here is 3,800 multiplied by 1 minus 0.15 multiplied by your T again. Okay, dividing both by 3,800. Here it's going to give you 0. And here what is left is 1 minus 0.15 t. Okay, the same thing we did earlier. We just put on the other side. Or so that's going to give you negative 1 is equal to negative 0.15 t divided by negative 15, negative 0.15. So here, if we're going to divide negative divided by a negative, that's going to give you a positive. So that's going to give you around 6.6667 years, or to estimate it, that's around 7 years. Okay, so that's the answer to these two questions in here. So in summary, in this video, we only studied simple depreciation, which is also known as the straight line method. And the formula for this is A is equal to P1 minus RT, which is actually based on simple interest formula. A is equal to P1 plus RT. Thank you so much for watching.